In this video, we're going to talk about the parabola. A parabola is the set of all points in a plane that are equidistant, that means the same distance, from a fixed line. That fixed line is called the directrix, that's this line, and a fixed point called the focus. So any point on the line, you can see from this sketch that this point P, it's the same distance from the focus as it is from the directrix, and that would be true for all points on a parabola. Now, you're probably used to seeing the parabola in this format. The first one is y equals ax minus h squared plus k, and the other one being y equals ax squared plus bx plus c. So the first one is the vertex format of the parabola, and the second one is the one where it's multiplied out, and you would have to put it into the vertex form or use the little short formula that the vertex x is the opposite of b over 2a, and that's what they're saying right here. However, we're going to look at the parabola in a slightly different form so we can find the focus and the directrix. So the standard form of a parabola with a vertex at the origin, so that's important, we're talking about only ones at the origin. There are two formats. Okay, the first one is y squared equals 4px and x squared equals 4py. Now when y is squared, you're going to have a non-function parabola. So it's going to be on its side that way or on its side that way. And of course, that's not a function because it fails the vertical line test. But it can still be a parabola. It'll have a focus, and it'll have a line over here called the directrix. And that distance here and here are going to be equal. So the distance between the focus, which let's say it's here, and the directrix has to be the same, because remember, every point, including the vertex, has to be the same distance from the focus as it is from that directrix line. So here are some sketches. I know they're a little fuzzy. You can look in the textbook and see them a little clearer. But in each case, when you have y squared equals 4px, that's when the parabola is going to be horizontal, and it's not a function, but it's still a parabola. You'll notice that the directrix is at x equals negative p. So we'll have to find that value p in order to find the equation of the directrix. And it's a vertical line, so it'll be x equals. And the focus is going to be at P0, not the opposite of P, but exactly P. We take the opposite to get the directrix because it's going to be on the opposite side of that focus. And if the vertex is at the origin, focus is going to be on the right, then the directrix is going to have to be a negative number. And then it could be going in the other direction as well. So your directrix would be over here. All right, and you'll see some as we do these. Now, if you have a function parabola, it's x squared equals 4py, and your focus, again, we have to find that value p, is at 0p, and your directrix, that equation is a horizontal line, so it's at y equals the opposite of p. So again, if this is at y equals 2 for your focus, so it would be 0, 2, then this would be y equals negative 2. Now, if we move the parabola away from the origin, in order to find the focus and the directrix, we're going to be in this format. It's going to be y minus k squared equals 4p x minus h. So the vertex is going to be at hk. It's the opposite of what's in the x and the opposite of what's in here in the parentheses with the y. And it's in the order, the x has to go first, so hk, and it's always the opposite of what's in those parentheses. The focus for this one will be at h plus p, so again we got to find that p, okay, and k, and the directrix will be x equals h minus p. Now, there are a lot of formulas in this, but if you draw the sketch, it's really, instead of memorizing formulas, you can do this more intuitively than trying to make these formulas match. And again, as we do the problems, you'll see. Now, this is for the non-function again, so the y is the one that's squared. Now, on the function type parabola, x minus h squared equals 4p y minus k. We've moved the vertex to hk, no longer at the origin. And so the focus is going to be at h and k plus p, and the directrix is going to be at y equals k minus p. So that's your directrix. Okay, so we'll get to some of those, and you'll see, again, we'll try to do it more intuitively. You can have this chart, but it will really probably confuse you, so it's best to just sketch the graph, and then you'll be able to figure out where the vertex and where P is and that sort of stuff. Okay, and at the very end today, we're going to look at how to identify which of the conic sections that we've talked about. This semester we've done circles, parabolas, ellipses, and now we're doing the parabola. And they tell you this criteria, okay? It's a circle if x is squared and y is squared, okay? And a and c are equal, okay? So like a is 4 and c is 4, or a is 10 and c is 10. It's a parabola if a times c is 0. In other words, there's going to be an x and a y square, or you're going to have a y and an x squared. So in other words, only one of them is going to be a square and the other is going to be linear, and it doesn't matter which one, they're both going to be parabolas. Now, the ellipse is similar to the circle, except a and c are not equal. So instead of being a perfect circle, you get the idea, instead of being a perfect circle, it's going to be an ellipse because those coefficients are different. That's why you get this elongated shape. And lastly, they say that you have a hyperbola if a times c is less than 0. Well, that means one of the variables is positive, one is negative. Okay, so we'll go through each of these and identify some of these equations without actually having to graph them or anything. Okay, so here's our first homework problem example. So we have y squared equals 20x. They want us to find the focus and the directrix of this parabola. So we're going to do our format. Y squared equals 4px. And so look, we've got y squared equals 20x. So what that tells us is that 4p has to come out to 20, so p has to be 5. Okay? Now remember, in this format, when it's y squared, your focus is at p0, and your directrix is at x equals, it's an equation, x equals negative p. So our focus would be at 5, 0, and our directrix will be at x equals negative 5. So when I look at these graphs, I've got to, remember, this is always a vertex at 0, 0 in this format. So all of these have a vertex at 0, okay? But I look at this and I say, okay, I've got y squared, that's a horizontal parabola, a non-function parabola, either this or this. So it can't be A, it can't be B, it has to be C or D. So I'm going to look for my directrix to be at -5, and that's a vertical line. So my focus is over here, 5, 0, and my directrix is over here. That's that line. So that if I pick any point on this, it has to be the same distance from this as it is from this. So D is going to be my answer for my graph. Number 2, similar type problem, only this time they ask us to actually graph it. If y squared is 4px, then we have y squared is 16x. Well, look, we've got the y squared and the x, so 4p has to come out to 16, so p has to be 4. So our vertex is at 0, 0, so I'm going to go over here and I'm going to draw this graph at 0, 0. Okay, and in my math lab, you won't get the graph until the very end, most likely. You know how it comes a little piece at a time. So you may want to just sketch it on paper so that when you get to the graph, you've got it completed as you fill these things in. Now, remember our vertex is at 0, 0. Our focus is going to be at 4, 0. Okay. So here's my focus, and I'm just going to put an F there and a V there, okay? Now, if my focus is over here, and it's 4 spaces away, my directrix line has to be back here, 4 spaces away, so it's at x equals -4, a vertical line. Now, if I've got to graph this parabola, I need to find another point that's appropriate, right? So I know I've got 0, 0, so that's one point, but I need another point. And so you can pick x to be 4, and then you can find what y would be. Even though this is already the focus, it's going to be, this parabola is going to wrap around it like that. So what we want to do is we want to find how high and how low it is when it wraps around that. So I'm just going to let x equal 4. So y squared is 16 times 4. Okay. And that means y squared is 64, and y is plus and minus 8. So plus 8 is right here. That's a point. And I believe that my math lab will, if you get that first point, it'll spread it out for you. And this is at -8. Okay. Now this distance here has a name. It's called the latus rectum. That's a Latin phrase. And it's useful in some applications, but we really won't be using it. But if you look at some of the videos that are in my math lab, they may mention that. It's just from the focus to the parabola, that distance by going through the focus and hitting the parabola. Okay. Number 3, this is in the x squared format. So x squared equals 4py. Now I know this one's going to be a vertical, so it's either be up or it's going to be down. Okay, and so they gave us x squared is -20y. So x squared is 4py. That means 4p has to be -20, and p has to be -5. Now the vertex is at 0, 0. Okay, and p is down here at -5. So that's going to be at 0, -5. That's going to be my focus. And then my directrix has to be on the opposite side. Remember, this is the focus. This is the vertex. It has to be on the opposite side, the same distance away. So it's this line right here. And that would be y equals +5. Now I'm going to find a point that will work, and you can pick x to be anything you want. This time I'm going to pick x, or I can pick y. It doesn't matter. Let me just pick y. Let me pick y to be -5, and you'll see why. I'm going to pick y as -5. That's down here at this focus. And I'm going to figure out where over here and over here this point's going to be. So x squared is negative 20 times negative 5. X squared is 100, right? If x squared is 100, x is plus and minus 10. So over here at 10, which is right there, I'm going to have a point. And over here to the left at 10, I'm going to have a point. And then I can get the basic shape of my parabola. It's a nice curvy shape. And that doesn't look too good, but you get the idea. In my math lab will graph it perfectly. And, you know, you're just doing a sketch. That's all you're doing. You just find one point, and then you can use symmetry to find the other point. Okay, so now we go into actually writing the equation given some information. So notice that they gave us the focus, 6, 0, and the directrix, x equals negative 6. So here's where I would just draw a little sketch. All right, so over here at 6, there's my focus. Over here at negative 6, here's my directrix. My vertex is here, and it has to wrap around the focus like this. So this is what it's going to look like. That's going to be y squared equals 4px. They gave me p when they gave me the focus. So I'm going to substitute a 6 in there for that p, and y squared is going to be 4 times 6x. So y squared is 24x. And that's all they want us to do there. Now we have a similar question, only this time, look, our focus is at 0, 6. Our directrix is at y equals negative 6. Our vertex is at 0, 0 still. We're going to wrap around this like that. So that's going to be x squared equals 4py. X squared equals 4py. Now, we want to make sure that we pay attention to what p is going to be this time. Now, notice this is opening up, so it's going to end up being x squared equals 4 times 6 times y. So this time it's x squared equals 24y.